All right, now we got the chain rule with triple composition of functions. There's going to be 3 functions now. There's going to be 6 examples for this. It's going to be a little bit long. I was going to make you not write it for the first one, and I'm still not going to make you write it for the first one, but I want you to write down the rest of the examples. So let's start with example 0. Now you don't have to write this one down. But first of all, these are the steps that I want you to follow. First, you'll look at this. You look at this, and you gotta think, okay, what are my functions that are acting here? I have 3 functions, and it's a composition of 3, and they're composed with each other, and I need to take the derivative. So I need to use the chain rule. So it says consider the functions with the graphs, blah 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 blah. Here's the function that we're concerned with. Now, I notice, I have a squared. That means I have an x squared function somewhere. I have an f of x function somewhere, right, with the f. And then I have a g of x function somewhere. Now, I want to see which is the most outside. So this is the outside one. And then f, if you notice, g is inside f, so that means this one has to be the middle, and then this one's the inside. So, here we go. The chain rule says the derivative of the, so if I do f prime, the chain rule says the derivative of the outside with the inside the same. Well, I know that the outside is x squared, so the derivative of that would be 2x. But here, I'm moving the 2 down in front, and then the inside is the same. Instead of having an x, I have f of g of x. There. And then to the 1 power, right? So that's the derivative of the outside with the inside the same, times the derivative of the inside. Well, what's the inside? You can easily see it. It's right there. And that would be, another chain rule. Okay, so the outside here is f. So I'm going to do the chain rule again. The derivative of the outside, f prime, with the inside the same, g of x, times the derivative of the inside. Well, the inside there is g. So you're just doing the chain rule a couple times. That's all. So now I have the formula. The derivative of the outside with the inside the same, times the derivative of the inside. So now I got that, and it's asking me to plug in 4. So I will plug in 4. I plug in 4. So this is what I'm concerned with. 2 times f of g of 4. I need to figure out what g of 4 is. Times f prime of g of 4. Same thing. Times g prime of 4. The problem that we were running in yesterday with some people was that they got confused between g of 4 and g prime of 4. Remember, this means look at the slope. So let's look at our graph. What is g of 4? That's what I'm going to be concerned with first. G is my red graph. I go to 4, and g is the y value, so it's 3. So this is 3. That means I'm looking at f of 3. Right? Yeah, Mr. D. That right. So I have 2 times, okay, times f prime of, well, g of 4 is 3. So I gotta look at that. Okay, and then what is g prime of 4? Alright, so if I go to 4, g prime is talking about the slope. It's the slope, so let's count. Rise 1, 2, 2 over 1. So the slope is positive 2. So this is positive 2. So I'll say times 2. Okay, now I start over, and I try and evaluate again. What's f of 3? F of 3. If I go to 3, f of 3 is just my y value, so that's 1. Okay. So I have 2 times 1 there, times f prime of 3. Now I'm looking for the slope. that slope is negative, and it's what, down 1, 2 over 1, so negative 2. So I get a negative 2 there, and I already had that 2, so I have 2 times negative 2 times 2. That's negative 8, and that's the answer. Ooh, that was nice. Maybe for this one, I suggest writing down, well, no, you don't have to write any of that down. Hopefully you understand. Wow, that took a long time. Let's move on to actual example 1. This one I want you to write down. Okie dokie. I accidentally already wrote the answer to this one, but here it says, what is the value of f prime of 3? That means take the derivative using chain rule, and then plug in a 3. It's a program 3. So, first, I'm going to write down my 3 functions, just like I did here, just so I don't get confused. I know I have an e to the x function. I have a square root function, and I have a 3x function. And I just need to decide which one's the inside most function, the outside, and the middle. Here, e to the something, the something, that's on the inside of this, so this must be the outside function. And then all the way on the inside is 3x, so that means the square root must be in the middle. So, now that that's figured out, well, the derivative of e to the x is e to the x. The derivative of square root of x is 1 over 2 root x. And the derivative of 3x is just 3. So, when I take the derivative here, when I do the derivative, you do the derivative, huh? The derivative of the outside with the inside the same. Okay, the outside is e to the x. So I do e to the square root of 3x. Derivative of the outside with the inside the same, times the derivative of the inside. Now I have to go to my middle function. Well, that's just, that's another chain rule. That's my middle function. The derivative of the square root of x is just 1 over 2 times the square root. However, it's the derivative of the outside with the inside the same. So I must keep this 3x in there. And then times the derivative of the inside of that, so times 3. That's how I use this. If you write it down, it becomes very easy, very simple, and you put in a 3. It's a 3. So f prime of 3, well, that's going to be e to the square root of 3 times 3 is 9. Square root of 9 is 3. That's nice. I'm going to have a 3 on the top, and then a 2 times the square root of 9. Well, that's just e to the 3 times 3 over 2 times 3. That cancels. So it's e cubed over 2, which I accidentally already selected when I took the screenshot. Okay, let's be done with this one. We're moving on to video number 2 with example number 2. Good day to you.